You ever wonder how a brilliant AI model, the kind you read about in some amazing research paper, actually makes its way into a tool that a doctor can use to, save lives? It's a really fascinating journey, and it's about so much more than just clever code. So let's dive in and break down this whole complex process.
Okay, so right out of the gate, we hit the biggest hurdle. A study in medical imaging AI puts it perfectly. The real challenge isn't just building a smart model, it's making it usable. Because, let's be real, a powerful tool is completely useless if it's a huge pain for a busy doctor to actually use.
And this really is the core of the problem for developers. How do you plug a new piece of AI into a super complex, high-stakes environment? Think about a radiologist. They practically live inside their picture archiving and communication system, their PACS. So the AI has to fit right into that system. If it makes a doctor open 5 different windows, forget it, it's already failed.
So once you've got this working model, you run into a really fundamental question. Where are all those complex calculations actually going to happen? The answer to this has massive implications for speed, for cost, and for security.
And really, this all boils down to 2 main options. You can run the model up in the cloud, or you can run it right there at what we call the edge, super close to where the data is actually being created.
All right, so with a cloud deployment, what happens is the data, say those medical images we were talking about, gets sent securely over the internet to these massive, super powerful servers. Think AWS, Azure, Google Cloud. They do all the heavy lifting, analyze the image, and then beam the results right back to the hospital.
Now, edge deployment, it's the total opposite. All of that number crunching happens right there, on site, on a local device. Maybe it's a special computer hooked right into the MRI machine. The key thing is, the data never even has to leave the hospital's private network.
Okay, so this is where it gets really interesting, because neither one of these is always the right answer. They both have completely different strengths and weaknesses. The choice is all about navigating the trade-offs.
And this table just lays it all out perfectly. You see, the cloud gives you almost unlimited power and scale, but you've got that delay, that latency from sending data back and forth. Plus, you absolutely need a solid internet connection. The edge, on the other hand, is lightning fast. It can even work offline, but you're limited by whatever hardware you have on site.
And get this, the industry trend is super clear. According to Gartner, by 2025, a whopping 75% of enterprise data is going to be processed at the edge. That's a massive shift, and it's all driven by fields like healthcare, where speed and keeping data private are just non-negotiable. It's quickly becoming the standard.
All right, so whether you've chosen the cloud or the edge for your AI's brain, the next massive piece of the puzzle is getting it to talk to the hospital's existing systems. An AI working in a silo is pretty much useless, right? It has to securely tap into patient data.
Okay, I know this diagram looks a little intimidating, but what it's showing is a really slick, modern way to do exactly that. You can see how it pulls patient data using a secure standard called HL7 FHIR. Then, it combines that info with what a doctor is asking, checks it against its knowledge base, like clinical guidelines, and then it even checks its own answer for accuracy. It's a super smart way to make sure the AI's advice is both personal to the patient and backed by solid evidence.
So let's just boil all that down. The crucial takeaway here is that the system doesn't just guess. First, it gets the patient's whole story, their history, their meds, everything. Only after it has that full context does it look through its medical knowledge to create an answer that's actually useful and tailored for that specific person.
But look, just getting the tech to work, that's only half the battle. Not even. To be used with real patients, an AI has to be proven to be safe, effective, and totally trustworthy. And you better believe regulators like the FDA in the United States have a very clear playbook for this.
Yeah, for an AI to actually get the green light as a medical device, the creators have to lay all their cards on the table. We're talking clear instructions on how to install and use it, a full description of how the model works, exactly what data it was trained on, and this is critical, a plan for how its performance is going to be monitored over time after it's out in the wild.
And that last point completely changes the game. It means deployment isn't the finish line, it's the starting pistol. It kicks off this whole life cycle of constant monitoring and updating. You have to make sure the AI doesn't get worse over time as it sees new kinds of data or as medicine itself evolves. This is all about managing its entire life. And all of this brings us to one of the biggest, most important questions for the future of medicine. As AI becomes, a core part of the medical team, who's responsible when it's wrong? That's a massive ethical and legal question, and honestly, we're just starting to figure out the answer.